Welcome to the 6th video in the Day of Datomic training series. In this final video, Stu Halloway will cover the operational characteristics of Datomic and the things you need to consider when you're planning your system. Stu will also talk about caching in Datomic as well as indexes and the indexing process. Finally, Stu will look at choosing a storage service, at monitoring your Datomic system, and at Datomic capacity planning.
To wrap things up today, we're going to talk about Datomic's operational model. That is, what it does when it runs, how the pieces fit together. This is stuff that you need to know in order to plan for running your system, but that as a developer you kind of hope not to have to know much about if things go well. So we're going to talk about Datomic's pervasive caching. So I've said that the database magically is available in every process in the system, and some skeptic on the front row has said, really, can the database fit in every process on the system? And the answer is, of course, it can't, maybe. So we want to have caching magic to help that happen. So we're going to talk about how that works. Datomic maintains a wide variety of indexes, and maintaining those indexes puts some work on every peer in the system. So I want to talk about what that work is. One, so that you understand how the system works, and secondly, so that you understand configuration settings that you might have to get into every once in a while to deal with indexing. Datomic is bring your own storage. So I want to talk about the different storages that you can use underneath Datomic and how things are stored in those storages. I want to talk about the transactor processes, right? The processes that ensure ACID writes in the system. And I want to talk about the peer processes, what it's like to have most of the database, right? Probably 75% of the binary code of Datomic runs in every process on the system. Right? The only part that's actually only in the transactors is the ACID write piece and some coordination pieces. But most of the code is actually an embedded library in your application, which is very different from a traditional RPC database where the thing that's embedded in your application is a little tiny client that does network traffic and then waits for some big machine in the sky to answer questions. Then we'll talk about the tools that you can use to monitor a Datomic system, and then talk about capacity planning with an eye to what kinds of jobs is Datomic good for and what kinds of jobs is Datomic not suited for. So let's start with a picture. This is a complete Datomic system. At the top we have your application server processes. So these are the peers. They have the Datomic peer library embedded in them. And those application server processes are talking to three other kinds of processes. They're talking to the transactors, which do ACID transactions. They're talking to the storage of record, whatever that is. And just for sake of completing the picture, we're going to have them also talking to a cluster of memcache machines. So in terms of counting machines here, we've got 3 application server processes. We have 3 little yellow boxes, so 3 machines in the memcache cluster. We have 3 boxes in the storage cluster, so we're running some kind of clustered storage. And we have 2 processes as boxes running transactors. One of them is a standby. Right? It's just there in case the other process fails. Now, there are a couple of things to see on this picture that are super important. The first thing is that the little blue circle that says query on it in the peer lib has 2 sources of data, not 1. It has the cache, and that cache is backed by all the indexes in storage. So Datomic makes all these indexes in storage, and that cache has access to them. And then it has a thing called the live index. The most recent, and I'll just throw out a number here, the most recent 33 megabytes of data that have been added to the system are cached live in every process. And then queries just merge those 2 data sets and treat them as a unified thing. Right? So you have this huge data set over here, which is the long-term state of your database. And then you have this short thing at the very front, which is the most recent stuff. And those things are automatically merged together in your peer. The reason that this is important is that anybody who tries to build something like Datomic naively will leave out the live index portion, and they'll build something that has to maintain these indexes in real time and update them after every transaction. And what they'll find out is they can't keep up, right? Because it's too much to rebuild these complicated data structures after every transaction. But there's no reason to build these complicated data structures after every transaction, right? You can rebuild them once every 32 megabytes worth of transactions. So that's what's going on there. The second thing is that when a query in Datomic needs information, the first place it looks is in cache in its own process. So if the information's already there, then it can answer queries even if the entire rest of the system is down. And it will answer queries at memory speeds. The second place it will look is in a memcache cluster, if you turn that on. You can leave out this piece entirely if you want to. And then the third place it will look for information is in the storage of record, right, where the stuff is actually stored in a long-term way. So in order to understand how your system is going to work and what performance characteristics it's going to have as you go to larger systems and larger databases, you need to kind of have this picture in mind. So what do you need to know to think about caching? First thing you need to know is that this is the easiest cache config job you've ever seen. There's one knob. How big do you want to make it? That's it. Right? Because what's the expiration policy? Everything's immutable. Right? Just expire never. Right? Memcache will throw out the oldest stuff, and you can hope that LRU is pretty good for you. But there's no other knobs. Right? It's just how big you wanted to make it. The second thing you need to know is that the stuff that gets stored in Datomic, in the storage server, is not individual datums. It's chunks of datums that are 1,000 or 2,000 or 3,000 datums that are called segments. And you can see this by going and looking at your storage. So let's see here. So I happen to be running Datomic against dev mode. Dev mode uses H2 internally. And when you're running in dev mode, you can try this on your own boxes right now. When you're running in dev mode, it also binds port 4336. If you bind 4334 for the transactor, it also binds 4336 to the web interface to H2. So you can actually go in here and look, and you can say, Datomic is storing things in a database that's keyed by ID and whose values are called val. And then you can say, let me go and look and select a val where the ID is something. And the IDs are all going to be UUIDs, and the vals are going to be base 128 encoded chunks of datums that are going to be several thousand datums per chunk. So the thing that gets pulled back into your local application process when you ask for a single datum is that datum and, let's say, 1,711 of its nearest friends. Those 1,711 of its nearest friends are likely to be usefully related to that datum. Right? Depending on which index you're walking, they're close to that datum in terms of that index. Plus partitioning will make them be close based on partition. Plus entities being assigned in time order means that if you make something like an order and its line items in one transaction, those things will all be contiguous in the database. This substantially mitigates and almost eliminates what people call the n+1 round trip problem. Right? When I go and get something, I get all the other stuff near it anyway, so I'm not going to have to make n+1 round trips. I'm going to have to make n over 1,000 or n over 2,000 plus 1 round trips if there's a bunch of data, which is 3 orders of magnitude different than the n+1 problem, and therefore no longer a problem. So segments are immutable, they never expire. Segment names are UUIDs, which means that if you have an existing cache in your system, you can just point Datomic at it too, and it will not interfere, other than competing for the space, with other uses of the cache. The combination of this cache naming and the fact that Datomic will run on top of SQL as a storage protocol means that people have been able to adopt Datomic without deploying any new infrastructure. Because think about what the pieces are. Right? You need storage. Well, you already use Oracle. You might want memcached. Well, you already use memcached. You need an application server where you already have that written on a JVM process. Now you have a Datomic library that goes into that process. You actually didn't change the shape of your deployment at all, necessarily, when adopting Datomic. So that's pretty interesting. And then, finally, the object cache, that first level of cache, is in memory in your process, which means that if you get good hits on that cache, Datomic will outperform an RPC-based database for looking up the data that it needs. So then you need to think a little bit about orders of magnitude and how long it takes to do things. And if you haven't thought about this before, it might not be obvious. So let's walk through it. That cache that runs inside of your peer library is formatted as Java objects, right? Because they're ready for immediate consumption. It's the actual datums. It's the actual things. I'm going to call the capacity of that cache order of 10 gigabytes per peer. And what I'm arguing here is that it doesn't make sense typically in terms of JVM garbage collection to have 100 gigabytes in a JVM processor. It's not going to go well. So order of 10 gigabytes per peer, and probably smaller than that, right? The recommended production setting we have for people getting started is 2 gigabytes per peer in a 4 gig JVM. The latency of things that are hitting that cache is going to be sub-microsecond, right? So that straight up beats any database that has to make an RPC call, right? Anything you can find there. Then the next layer is memcached. Memcached has zipped freshened binaries. The capacity of the memcached layer is how much money are you willing to spend provisioning a memcache cluster. We have users of Datomic that have we have a user of Datomic that has a 200 gig memcache cluster, and after reviewing their performance, I recommended that they go to 800 gig in their memcache cluster because they care, right? They want to get their data back really fast, and the speed of hitting something in the memcache cluster is order of a millisecond. It depends, right? These are all, by the way, these are all order of magnitude. So they could easily be half as much or double these numbers that I'm saying. I'm not trying to make hard numbers here. And then finally, if you have to go all the way to storage to get data, then it's going to be zipped freshening again. It's the same stuff that's in memcache. And going to storage is order of 10 milliseconds. Again, this is an order of magnitude. I've seen systems get things from storage in 2 milliseconds. I've seen really big systems that can't go faster than 40 milliseconds. It's because of the way that they're configured. So within these numbers, you've got to do your own experiments if your system is super performance sensitive. Questions about caching? Yes?
Didn't have time to see when you showed it, but if the storage is not available and you make a query and it's not in cache, do you get an exception?
Yes. So the question is, what happens if one of these layers, if all of these layers fail, basically, you're going to get an exception. You're getting an exception that says, I couldn't get the data. Right? So Datomic is never inconsistent. It's never incorrect in your data. It will always choose to be unavailable, rather than say, oh, this data wasn't here, so I'll give you the part of the data that I had, and you should just pretend like that's the data. Right? It's never going to do something like that. But this also means that if you have memcached, and you've got a big memcache cluster, you could take down both the transactor and storage and still serve all queries if your memcache actually has everything in it. So there are a lot of operational possibilities here. So the next thing to understand is this indexing split. All the most recent datums are cached in something that's called the memory index in every process. And the way Datomic works is when that memory index reaches 32 megabytes, Datomic says, I should kick off a background indexing process. It then puts those things into the storage indexes, and then that memory is reclaimed in all the peers. All the data that's older than the most recent 32 megabytes is in the tiered distributed cache, the thing that we just talked about. The indexes themselves are trees with a very wide branching factor. So the trees are only 3 deep. So the branching factor is thousands. The root of the index is always in the cache. Right? You have to get the root to even start the database. So that's one segment that's pointers into directories. The directory tier will always fit in the cache on a system because it's at least 1,000 times smaller than the actual data. And then the actual data of the database, the leaf nodes of this, there's broadly speaking, well, there's a variety of possibilities. If you have a very small database, then those will fit in cache too. And then all of your queries will happen at memory speed, and Datomic will downright spank any RPC-based database. Or you might be in a scenario where you have a really big database, and so on average, you never find the leaves. Right? You're working your way, you're doing analytic type scans, and so by the time you get back to the segment you wanted to look at before, you've flushed it out of, it's not going to be in cache. In that case, how far away are you from your data? Well, if your memcache is big enough, you're a millisecond away per segment. If your memcache is not big enough, you're 10 milliseconds away per segment. And now you can sort of sit down and do the math and start thinking about, what are the performance characteristics going to be in my system. The vast majority of customers, to our surprise, have not bothered to provision memcached. Because what they found is the system performs well enough, right? They just don't need that performance boost. But the ones that do, really have liked having it there. The other thing that's important to know about these trees is that the history is in a totally separate tree, which means that when you ask questions that don't have to go to history, you never even touch those segments. So one of the common questions people have is, am I constantly paying some sort of penalty in terms of my I/O or storage or what data I keep in memory because I have history around? And the answer is, you pay that penalty when you ask to pay that penalty. Right? If you want to ask a history question, then you're going to have to pull segments related to history. If you do not ask a history question, then those segments are never going to be pulled. Yes, question? Yes?
Maybe it's unrelated, but I'm thinking about the sorting case, like let's say gather the last 20 questions. In that case, since we do the sorting in process, let's say we have 100,000 questions, like does it have to log all of them and then do the sorting the language itself? Would that be slow?
So the question is, if I have 100,000 things, does it have to load all the things if I want to then sort them or do something with them? And there are a couple of different answers to that. One, in the general case, if something actually requires looking at all the data to get an answer, then somebody has to look at all the data to get an answer. And so in that sense, Datomic is not different than any other database. Right? Where it gets looked at may be different. It may be in your application process as opposed to some server process. But if you have a question that says, I have to look at all this information in order to answer it. Now, a separate question is, which questions require looking at all the data in order to answer them? So Datomic does not make a lot of optimizations in this area today, but we are talking about making optimizations like this in the future. So if you say, for example, I want all the things that cost more than 1,000, we could get the things and walk through them. Or we could use the predicate to only go to the index, the part of the index that's already bigger than 1,000, and only get those things. There are other kinds of optimizations like that. So over time, I expect Datomic to add optimizations that change the answer to the question, do I have to look at all the data to answer the question? The other thing I would say is that looking at 100,000 things is, milliseconds once they're in cache. So, ripping through 100,000 things or 1,000,000 things is tiny. That's not where you start to worry about these questions. You need to multiply your problem by 2 orders of magnitude. Right? If you have to look through 10 million or 100 million things, then you start actually being very careful about what you're doing with query and so forth. Yes?
Just to be sure, this index is about the most recent values for every attribute, or is that the historical index?
Both history and the most recent look like this, but they're in different trees. There's a separate tree for current values. Right, separate tree for current values. There's also a separate tree for each sort. So there's an AVET tree and an EAVT tree and an AEVT tree and a VAET tree and so forth. Now, how does this indexing happen? The transactor, as a background process, makes these indexes. Right? The transactor knows when the need happens because it's the one doing the raw writes. And so it'll notice that we have 32 megabytes accumulated. It'll start making these background indexes. Indexing can fall too far behind. Right? So we start indexing, and everybody's got to hold 32 megs of stuff in memory. Well, what happens if it takes the transactor a long time to do the indexing job, and people are keeping adding stuff? What if we get up to 40 megs? What if we get up to 60 megs? What if we get up to 200 megs? Right? Eventually, there's some limit where you have to say, you know what, we have so much in memory now, and the indexing job, the background indexing job that releases that pressure hasn't finished. When the transactor hits that limit, it will throttle writes. So what it will do is it will start taking only one write every minute, or something like that. I mean, it will take, so it's essentially unavailable. Right? It still takes a few writes, you can still tell it's alive, but it will essentially become unavailable until indexing catches up. You will only see this during import jobs. So the reason that, in ordinary operation, this will not happen. But during an indexing job, or during an import job, where you have, I have all the data from 5 years in my system that came in over, 1,500 days, but I want to pour it into the system in, 1 day right now so that I can, start the system running again. You will see this happen then, and so I want to make you aware of it so you understand what's going on. And we'll talk about, why and how this won't happen in ordinary use in production. So the next thing we're going to talk about is storage. Datomic supports a wide variety of different possible underlying block stores, and I have listed on this slide in the order of popularity as best I can tell from talking to people. So this is an informal notion. So DynamoDB is Amazon's cloud storage, and so almost everyone who's running Datomic in the cloud uses that. Lots of people use SQL, especially Oracle, and some MySQL, Postgres, some SQL Server. Increasing numbers, especially recently, of people using Cassandra, a few people using Riak, and then relatively fewer people using Couchbase or Infinispan, and then dev is really for dev mode, so everybody uses that, but I listed it at the bottom anyway. So your question is, if I have to choose the storage that I'm going to run with Datomic, which one should I choose? I can tell you by far the easy answer. Choose whatever your insect overlords think is the storage they want to run. Right? Whichever one the political power holders think is the right one, you should use that one. Right? And the reason for that, it is partially the reason for that is because that's how you're going to succeed. The other part is that a lot of things that people worry about when choosing storage are not as important. Datomic insulates storage from load. Right? It's not a right scale system. So we're going to categorically rule out some kind of loads in a minute where you really start to care about storage. It caches things locally, immutably. So lots of things that you would need to read, you're not actually going to read from storage. You're going to read it from your cache. And Datomic tolerates storage latency, again, because of the caching. So the ability of your storage to handle raw volume is less important, and the ability of your storage to be non-latent is less important with Datomic than it otherwise would be. On the other hand, that makes other things more important. I think you should care about how reliable is the storage. When is it going to crash? Right? If the storage crashes, you're still going to have to recover that from backup or whatever. Right? The world hasn't changed. Right? If that thing falls apart, it's the same problem it ever was. Likewise, manageability of storage and familiarity. And familiarity can also include political possibility within your organization. So those are the things I would primarily look at when thinking about storage. Now I want to talk for a moment about transactors. What do you need to know about the transactors in the system? Well, transactors have a couple of jobs that we've already talked about. Right? Their job is providing the ACID transactions. Their job is to stream the most recent change out to the peers so they know what's going on and keep up. Their job is to manage the indexing job. There's one other thing that transactors need to do, which is stay up. Right? You don't want your system to go over and become unavailable. And so the way this works is when you start a Datomic transactor, if you configure it with that transactor properties to point at storage. If you point two transactors at the same storage, one of them will get in first and it will become active. The other one will get in second, see that that one's active, and it will become the standby. The thing that's cool there's a couple of things that are cool about this. One is it's dead simple for the user. Literally all you do to switch from low availability to high availability is start two processes instead of starting one process. Right? The other side of that is what the development team at Cognitect had to do to make it work is incredibly simple and therefore less prone to subtle bugs. And that is the transactors are not trying to coordinate about the operation of the system at all. All they're trying to coordinate about is who can see storage. So the active transactor writes to storage every 5 seconds. I'm good, I'm good, I'm good, I'm good. And it uses a conditional put. So it's I'm good and I was the guy that made the most recent write before this. I'm good, so it's a hand over hand write. Right? I'm good 11, I'm good 12, I'm good 13, I'm good 14. The standby transactor watches. And if it ever sees 10 seconds go by without that hand over hand, it writes, I'm now good, 17, and takes over. Guess how much else we had to do to implement this? Everything else is immutable. Right? The transactor is not doing storage. It's not doing storage is totally separate. So a lot of high availability systems that are built on traditional architectures, they deliver the same thing, but it's a lot more nuanced in terms of its implementation. Right? This is a very clean, simple implementation. And I also just documented for you kind of what the failover time is going to be, which is 10 to 15 seconds. Because it's going to take that long to detect a failure and then kick up the next guy. And there's configuration knobs on all this stuff, but that's kind of the default behavior. Now let's talk about the peers. So the peers are the thing that users actually use. These are your application processes. These are your application servers. So what do you need to know about them? Well, this is different, right? In order to use Datomic, you have a much more substantial library embedded in your application server. Most people choose to do this directly, right? They choose to say, we're going to take our existing application servers and embed stuff in it. But every once in a while, people will say, you know what, I'm going to introduce a whole new tier. Right? They'll say, I'm going to make a Datomic service tier, and then put REST endpoints or APIs or whatever, and then let another tier call into that. Entirely up to you. Important things to know here. Query load never bothers write load. Right? Because query load happens on your peers. It doesn't happen on the writing system. It doesn't even talk to the writing system. And it answers queries in memory via cache when it can. Datomic peers will, by default, grab half the RAM in your system for the cache. Half the RAM that the JVM provides. If that number is not right for you, change this setting, datomic.objectCacheMax. If this setting is incompatibly high, it'll refuse to start, as some of you found out in the labs. Right? If this setting is so high that Datomic plus ordinary use would automatically end up using more than 100% of available RAM, it's just going to die on startup and say, don't do that. But this is easy to manage. Most of our users either use this number or occasionally some people turn it up. Right? But you can imagine scenarios where you want to turn it down. Part of being a peer is you're the only person who knows what goes on in your address space. Right? You might have some big in-memory data structure that you keep. Right? You might have a multi-meg data structure that you keep. So I don't know. So it's up to you. This is a picture of Datomic's monitoring. We're not going to go through this in detail, but what I want to point out is that this is another picture of the same kind of, it's shaped a different way. You have the transactor over here and storage up there and memcached over there, but it's the same processes that constitute a Datomic system. And the thing that this picture adds is the gray boxes. The gray boxes are the names of metrics. And the important thing to notice is that every communication has gray boxes on it, which means that every way in which Datomic processes interact with other processes, there are metrics that you can watch and see what's going on. So for example, this is viewing a metric called log write milliseconds. So log write milliseconds is actually not even shown on this picture. There's more. Yeah, so this is actually part of transactions as well. Transactions have to write to the log. So in addition to transaction milliseconds and transaction bytes, there's also log write milliseconds. So what this is showing is the mean of the transactor log writes over some time period. And the mean looks like it's around 11 milliseconds. So remember before I was talking about storage latency being on the order of 10 milliseconds. So here you're seeing that on the right side, 11 milliseconds, although the mean was quite high during some 20-minute period here, whatever. It was up to 14 milliseconds. This is CloudWatch metrics. So Datomic can automatically produce CloudWatch metrics even if you're not running in the cloud. So I run on my dev laptop and then put the metrics in the cloud just so I can use these viewing tools. It also provides a programmatic endpoint that you can call out to for these metrics. In that case, you can put them wherever you want. So our users that are in production, they almost always have their own. The bigger the company is, the more likely they are to have their own special highfalutin thing. So they all put their metrics wherever they want to, and they call out through the endpoint to do that. The other thing I will say about this that has been true for the last several releases of Datomic is that you'll notice that this original picture doesn't show the peer processes. When we first released Datomic, we didn't actually report metrics from the peers because they're your processes. But it became evident that Datomic is doing enough interesting stuff in there that you might want to. So the same programmatic hook that you can use to capture metrics from transactors, you can now use to capture metrics from peers as well. And peers, they also talk to storage, they do things. So you can also capture those metrics if you want to. Here's one other example of metrics, and this shows a very important thing. There are metrics whose name begins with alarm. There's a half dozen of them. The documentation is, if you have a metric whose name begins with alarm, call support. Right? This means there's something that's happening that is bad, and you don't want to have it. Now, this is actually the least bad one, because this one can happen during an import. This is alarm back pressure. Alarm back pressure happens when the transactor says, I can't keep up, I can't make the index fast enough, I'm now going to start being unavailable. So the way I made this happen was I ran an import job that poured transactions onto the system as fast as possible. And if you do that, you're going to get here. And it was creating these warnings 4, 5, 6, 7, 8 times a minute or whatever during this time period. So you're not going to see that except during an import. If you see any of the other alarms, call support. Right? They all mean something has happened that is problematic enough that it could cause unavailability or something that you need to take action on. And that's why they all have a naming convention so that you can write in your own monitoring tool some sort of regular expression that says, all these things, take very seriously. So now let's talk about capacity planning, putting this all together. How big a system should I put into a Datomic database? Well, here's my rough estimate. Right? If your data size is 10 billion datums or less, that's a good fit for a Datomic database. If it's more than that, not so much. Is that an absolute hard limit? No. We have users who are up at 30 and 35 billion datums. But definitely at 10 billion datums, things get challenging in various ways. How do I figure out how many datums my system are going to make, since Datomic's the only system in the world that makes datums? You take your tables in your existing SQL system, you take your rows, you multiply them by your columns, and you add them all up. Right? So if you have a system that has one table with 1 million rows with 10 columns per row, that's 10 million datums. Right? And subtract out any nullable columns that don't get used. So if you have a massively sparse table, you can subtract those back out because Datomic doesn't have to store anything for sparse things. So that's how you sort of figure out if the size is going to fit. Yes? Is there a lower limit on the data size? I think that anything less than 2 datums would be unwise to store in Datomic, because I think if you have only 1 datum, you don't have very much interesting data. No, there's not really a lower limit. And actually, one of the places where Datomic has been interesting is for people who are doing storing of configuration, which is often very small, modest amounts of data, but the time series aspect of it, like the configuration was this last week and then we changed the configuration of that, there are lots of people who would be like, you know what, I would love to be able to go back and see what the configuration knobs were on my system 2 weeks ago when this happened, but they don't have that information in a database anywhere. Now,
the reason I asked that is like on databases where distributed systems like Hadoop or everything, so if there is a lower limit, sometimes Arctic suggests that if your data is not that big, don't even go to that.
no, I think especially when you have something like dev storage, right? If your data is both tiny and you don't care about availability and near inconsequential, you can run dev storage. It's all running in one process. That's kind of the like micro system type scenario. So no, I don't really think there's a bottom size. How much write volume can Datomic take? Well, this is a real limit. Right? Your write volume needs to be consistent with that data size in the long run. So if you're writing 1 billion datums per hour, are you consistent with 10 billion datums ever? No, right? Unless your system is only going to run for 10 hours. Right? So you need to go back and do the math and say, what's my write volume over time? Yes?
When you say a data size of 10 billion datums, is current value or including all the history?
Including history. Yes?
Archiving, once you get to 10 billion, then archive.
So both of these questions have to do with, well, maybe my data set is like, isn't that big, but its history is that big. Yeah, so there is a feature in Datomic today called no history. You can put no history on an attribute, and then that attribute will not collect history. These are real hard limits. There are certain kinds of things, and I'll talk about specifics in a minute, that you just shouldn't try to put in Datomic. On the other side, read volume, Datomic looks really great, because if you need to read more, all the parts of Datomic that read are scalable, and depending on what you choose for storage, elastic. Right? You can make your storage, especially like Amazon's DynamoDB, right? You want more, you just, Amazon's got a great business model, right? You just pour more cash on them, and they pour more storage on you, and everybody's happy. And likewise with your peers, right? If you need more peers, start more peers. So Datomic is a great fit for systems that might have to do a lot of reads relative to the amount of writes that they do. There's some housekeeping that you need to be aware of. Datomic makes these persistent data structures. Persistent data structures make garbage. You need to collect garbage from your databases, and you need to collect garbage from deleted databases. The capacity planning links there tell you how to do both of those things. Those things put load on storage, right? Because they're going back to storage and saying, get rid of this, get rid of that, and get rid of the other thing. It's important to do this and test this as part of your ongoing load analysis for your system, because otherwise what you can do is you can configure storage that's perfectly good for keeping up with the current load, barely, but it's not good enough to keep up with the current load barely, plus I also need to clean up the garbage every once in a while. So this is not a huge problem, but you need to do it think it through in advance. And then for caching, my recommendation is that you test and monitor. So you put in data that's representative of what you need, And you can look at, there are CloudWatch metrics or raw metrics that will show you which tier you're hitting the cache. Right, so you can run a series of interactions against your system. You can find out what the memcached hit rate was, how many times you had to call out to memcached, how many times you hit the object cache, and so forth. You can get metrics for all those things and sort of configure that. So having taken that all in, Datomic is not good for some things. It's not good for write scale. Right, there are some things that want to put in a trillion things or a quadrillion things. Right, if you're talking in those numbers, Datomic's not a fit. It's not good for media storage. Right? Unstructured documents, like Word documents, audio, video. Right? No sense in putting anything like that in Datomic. It's not good for something that's churn, where the history is not sensible in anything except the aggregate. Right? If I have a counter that counts how many times something's been clicked on a web page, right? I don't need to know that before it was 1,000, what was its value before that? Anybody want to guess? It's a counter, right? Its value before that was 9,999, and the value before that was 900,000. Like storing that kind of thing it doesn't make a lot of sense. So there's lots of things that fit this. Big data, graphics, video, log file analysis. Anything that people are legitimately reaching for Hadoop for. And I did emphasize the word legitimately because I think that there are things that people are making into big data problems that are not necessarily big data problems. Not a good fit. On the other hand, Datomic is a good fit for things. It's a good fit for valuable information of record. Right? This is a system of record database. It's an ACID database. This is going to give you the reliability that you're accustomed to having with your information that you have from, say, a relational database. It's a good fit for people who want agility in development. I want to be able to try different things. I want to be able to move my schema around. I want to be able to have flexible schema. I want to be able to have operational flexibility. I want to be able to say, I want to run against Oracle today because that's the corporate mandate. I want to be able to run against Cassandra next year because that will be the corporate mandate. And I want to be on DynamoDB 2 years down the road because that will be the corporate mandate. Obviously, if you need history, Datomic is a fantastic fit. And I hope if I've convinced you of one thing in this class, that it's insane that developers give themselves history with source control and they don't give their users history in their databases. And then it's a great fit for read scale. Right? Immutability enables read scale. So you can say, I want to be able to serve a lot more reads, and I want to be able to expand my system just by adding more machines, not having to code in a different way. And so there's a ton of scenarios here. Transactional data of any kind, online stores, business records, medical records, financial records, scientific records, inventory, configuration of systems, web applications, departmental databases, and cloud apps, and many more. Those are areas where we've seen people be successful using Datomic. And so for the final lab, what I want you to do is I want you to take your sample data set that you worked on today, and I want you to do an assessment. How well does it fit Datomic? And in particular, I want you to create a comparison matrix. So I'm going to give you a small number of characteristics, and then for each one of those characteristics, I want you to say, given my problem, would Datomic be beneficial? Why? Or would it be detrimental? Why? Or maybe that characteristic just doesn't matter. Right? It's irrelevant to me. And then also, compared to what? Right? So you're not going to, you're going to do this problem somewhere else. You're going to put it in something that's not like Datomic. What are the implications around that aspect? And when I said that the comparison matrix was going to only have a few things in it, I actually lied. So for each one of these things, and you might cherry pick, for each one of these things, take a sheet of paper, write down each one of these things, and then say, how does this affect me for the data system that I might try to put in Datomic? Is this going to help me? Is it going to hurt me? Or is it going to be irrelevant? The other thing that this accomplishes is that by working through this list, you will test yourself on all the different things that we talked about today and be able to go back and say, oh, if I don't even know what that is, I can go look that up in the docs, or Stu's going to be around during the lab, and we can say, what is that and how might it affect me in my system? And with that, we're going to end the presentation portion of this. I want to thank everybody who came out for the day of Datomic. People could reach me via my Twitter handle @StuartHalloway or at any of these links, or stu@cognitech.com. And I will be moving around the room helping people with the labs. Thank you very much.